What up? What up? What up? Hello, 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 hello. Okay. First of all, um, I would like to welcome myself to Twitch. This is my first stream. I don't really know how Twitch works, but yeah, I wanted to do some really cool programming projects, and here we are. Um, okay. Um, I don't really know if anybody can hear me. Mm, mm, mm. Okay. Yeah, good. Good, 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 good. Okay, so let's jump right into what we are trying to do. So, there is this guy called Soding. I don't know if you know about him, but he is a um, pretty big streamer, I would say. He does these recreational programming sessions, which I find very intriguing. I've learned a lot of stuff from there. And today we are going to look into one of his creations, which is called Panim. It's a way like this is an application which will let you to create programmatic videos or animations using C code. So how this works is you have this Panim library or the executable which you pass this um, dynamically linked libraries. And based on these dynamically linked libraries are compiled as plugins for this Panim, and it if you want to learn more about Panim, I would suggest to watch Soaring Streams. He does a really great job on describing what's going on. But uh, Recently, a couple of days ago, I don't remember exactly when, but a couple of days ago, he created one of like a plugin which basically lets you render animations. Uh, let's look into the code so it'll be easier to explain. So, um, mm, 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 mm. Wait, plug update is this one, plug finished is this one. Okay, so let's start from the beginning. So basically, he has like a structure defined for the for some stuff. So what this basically does, I can't really run it because he's compiling this for macOS and the entire, or he's rather compiling it for Linux, and I'm using macOS, and I can't really use this. But I wanted something similar to this. Here, what's so fascinating about this project is he defines these animations as a sequence of functions. So let's say here he says like play a sound, then you apply some animation here, and then you sleep for a second, or sleep for, I don't know, some time. Wait a second. Sleep is yeah, for 0.25 seconds, and then he plays another sound, and he plays another animation and then sleeps again. Basically like uh, um, in in his implementation, um, animations are like a sequence of functions. A function executes for some time, and then it finishes, and then the other one executes, and so on and so forth. And what is interesting about this entire thing is he created coroutines just to implement this non-blocking rendering, and you can see like it includes a lot of assembly code, which is targeted specifically for x86 assembly as far as I remember. So even if I were to compile this to macOS, it won't run because of the platform specific assembly code. So um, but the concept for these coroutines is exactly similar to that of fibers in PHP. Let's see fibers. So what exactly are fibers? Well, fibers, how do I explain this? So fibers allow you to suspend the calling of a function. So let's take this much as an example. So for example, there is this function, and here you are calling fiber suspend. What this does is um, whenever your program execution reaches here, so what this suspend does is it basically uh, halts the program, right? It halts, not exactly halts. It temporarily suspends the program. So whenever you call this fiber, like you have this resume method in fibers. So whenever like later down the line, whenever you want to uh, execute this part of the code, you just call resume, and then it will resume calling this function. So you can it's I don't know, it's kind of like the coroutine implementation that Soding has done, and it's like the concept is pretty much coroutines in any other programming language. So they just give a fancy name for for this fiber thing, but it's actually a coroutine under the hood. So what you can do with fibers? Okay, so you can check if a fiber is started, which means if a function is started, uh, and fiber start basically starts the function call. A fiber is suspended. This is when like your um, all this like the entire fiber thing, we are doing it so that it the entire program is non-blocking. So you can like spin up multiple fibers or multiple coroutines or whatever, and like they do not block each other. And in this example, like how Soding is using here is let's go through the update thing. Where's update? Yeah, okay, so here. So this blog update will be rendered in every frame of the animation, right? And here he's resuming a coroutine, and he gets a coroutine from, I don't know, this P is something. I don't really know what P is, but so from somewhere he gets a coroutine and then he resumes it. So for every frame, he is like trying to resume the list of coroutines. So what coroutines are like these functions. You see, co-tween, co-sleep, play sound. I don't know if play sound is coroutine, but co-tween, co-sleep, co-tween. These things are coroutines. Um, these things are coroutines, and he's trying to run this thing in every function, every frame. And um, what happens, let's say you call cotween, right? And then let's say the current coroutine is cotween, and you basically what this does is it renders like one pass of this cotween function in one frame, and then when you get to um, the other frame, it might be executing cotween, or it might move on to some another function like, I don't know, co-sleep or whatever, something like that. I think it'll make more sense when we implement something similar in Fiber in PHP. But before that, I think we need to like create some sort of uh, bindings or FFI bindings for Raylib in PHP. So let's github.com/race and Raylib. Let's go here. It's releases. Let's go to the releases. And let's download this format. I didn't really want to do this. I want to copy clean address, and then from my trusty old terminal, let's create git, and then this thing. Okay, we have Raylib now. Minus x Raylib. Okay. Don't here. Okay, we have Raylib. Now I'll just composer init. Yes, and just so that we can easily render, maybe I'll add some composer require dev dumper, just so that I will have a relatively easy time debugging this entire thing. Okay, so let's open this thing in Vim. We have now Raylib source code. We have Symfony var dumper and nothing else. And if we see composer JSON, oh shit, there's another. I wanted to see this. And we have, okay. Now, first thing would be to create some kind of FFI bindings for Raylib for PHP. So I will just create a raylib.php class, declare strict types PHP anim. Okay, so so before we implement anything else, I would like to show you PHP FFI things. I created a video in YouTube before, which basically explains how we can use FFIs to run native functions. But yeah, I think it's better if we go through it again. So um, if we look at this Raylib source code that we just downloaded, there are two folders in it, lib and include. So lib contains a dynamically linked library. It's for macOS it's dylib, and for Linux it will be something called raylib.so or something like that, and for Windows it will be I don't know, raylib.dll or something like that. So what these files are is let's go to who is Raylib? Yeah, Raylib. So what these files are is the entire source code of Raylib. So if you look inside src, we have all these things. So these things are compiled into a dynamically linked library. What DLLs are, you can search about DLLs. Yeah. So it says shared library in Microsoft Windows. It's not Windows only thing. It's for any other operating system. Well, actually, the DLL is specifically for Windows, but dylib for macOS and .so for Linux systems. It's basically the same. So what this thing does is it contains the function definitions, or let's see, I first. Foreign function interface. And the FFI, yeah. So this we've established that the DLL files contains the functions that that the source code for its for which it was compiled for contains. So for example, for Raylib, we have let's see, raylib.h. Let's find some functions here. Let's say init. Okay, so you see, we have this init window function which really provides, right? And so in the dylib file that we downloaded, or in SO or DLL in Windows, there will be a reference for this function init window, which we can then link and then call from our own program. What FFI is it's a way in any programming language to call these foreign functions. These are called foreign functions because it's not really provided by our language, but it's a mechanism from which you can call like functions of other languages or other executables or other dynamically linked libraries or whatever. Yeah. So what we need to do now in order to use Raylib is we need to create an FFI interface with the Raylib dynamically linked library that we just downloaded. So which is this thing. Yeah. And in PHP, there's a way to do that using PHP FFI API. So this is the thing that we will be using to interact with Raylib from PHP. Yeah. All right. So how do we get started with this? Well, actually, we are interested in this function, FFI cdef, which basically takes in a definition for the function that we're going to use and a library or the dynamically linked library. Yeah? And how this works is let's see if we have anything written here. Probably want to add here. Yeah, okay, doesn't matter. So let's try to do it. So I will public function construct, and here I will have private and definition. Actually, we don't even need. Let's just do it this way, and then this fi equals to ffi cdef, and we're going to code is our definition and lib is our path. Yep. Ffi, yes, and private we are not going to write here, so let's make it read only. Okay, so let's create an index.php here, then and then $raylib, or let's just say rl equals to new raylib. We need to provide path, which is dot slash, what was the path again? Raylib 5 raylib underscore macOS slash lib slash lib raylib.5.5.0.dylib raylib.5.5.0 and then the definition will be, let's create a definition. Okay, let's just use, and then we can got this to definition is this thing. Okay, now I I need to run tmux first. Composer dump autoload. Let's see PHP. Okay. Field loading PHP and Raylib. Okay. Was it libraylib? Yep, libraylib. Libraylib. Okay. So with this, what we have done is we have really linked with this what we have done is let me just clean up. Now so this FFI property now, it contains the reference to all the Raylib functions, structures, and whatnot present in this dynamically linked library. Now what we need to do is we need to figure out a way to call these Raylib functions from within our Raylib class. And to do that, I will use PHP's magic method, public function call. Let's do this thing and then return this what was name with arguments. Okay. Right. Now from here, what we can do is Raylib window and 800, 600, PHP anim, can't type it. Close window. Now, if we try to run the program as is, we're gonna get an error saying it could not find any init window and it could not find close window. That is because although like the library itself contains this function, we also need to provide the definitions of these functions and structure to our FFI layer, so that it actually recognizes that these functions are present, right? And to do that, we need to like create a string definition of the Raylib functions here. So I will split a window. I'll go to here and then I will open include raylib.h. So this file contains all the headers, and using this thing, we should be able to find in each window. There it is. And what we need to do is copy this much and just paste it here. And also for close window, we'll just paste here. It will be way easier if we could just get the contents of this entire header file and then just put this in the definition, but there is limited support for these definitions. If you see here somewhere, yeah, you'll probably want the C header files, but as of current version, preprocessor directives do not work. So what do? On system GCC, the files run through this command. Macros are not supported either. You'll probably still have to rewrite small wrapper unless you see library is exceedingly simple public API. Okay, it doesn't matter. We are not going to use any, we are going to write all the functions that we need here. So now, if we do this, init window, height, width, concept title. Maybe we can remove const. Init window, new window with height, pointer. Let's do it this way. We don't need incorrect number of argument for C function init window expecting exactly 3 parameters in Raylib 23. Okay. Here we were supposed to spread this sizer. Okay. Now we are getting somewhere. Now we're getting somewhere. So this, like the entire log that you see here, this is generated by Raylib during the initialization and like the entire lifetime of the project. So what's going on here is we were able to create a simple window. So the next thing would be to let's just persist the window and let's like try to draw some text in it, right? So rl no while not close begin drawing and then end drawing. Okay. This is going to be Boolean and this is going to be should window close. This is going to be void begin drawing and drawing, and let's see. Actually, it's Windows should close, I think. Let's verify. Yeah, Windows should close. Windows should close. Yeah. Okay. What? Where the fuck this TL come from? Okay. Great. Now that we have a simple window, let's try to make a okay. I want to fill the window with a white color of some sorts. So there's a clear background. Now this function, but this is going to be a bit tricky because unlike other functions that we've used so far, it takes in a structure. This is a color structure. So struct color, which is this thing. And yeah, we need to define the structure here as well. And okay, we define the structure, but we also like actually need to create a structure like this color object from Raylib using our FFI. So to do that, I think I will create. First, let's look into the FFI docs. So there's this new function in FFI which lets you do exactly that. So what you pass here is you pass the name of the type, which is color in our case, and then it will create a temporary data, which is C data, this C data thing, and then this C data is the color structure that we're looking for. So to do that, let's create a generic helper so that we don't need to like, let's say struct, and this takes in the name, and then something like this, and then it will return C data. Okay. So what we can do here is now type equals to this FFI new, and then name, right? And for each okay. So now how we can use this is, let's say white equals to Raylib, and then struct, we say it's a color, and now we need to provide R is going to be 255, G is going to be 255, D is also going to be 255, and A is also going to be 255. Now, finally, what we can do is clear background and then pass in white. All right, let's try it out. Good. Okay, we have white now. Now the next thing will be so with this generic thing, with this generic struct thing, now we can create any structures that are available in Raylib. So for example, we might create I don't know, a rectangle. Let's try to draw a rectangle. So draw a rectangle. Let's 0 semicolon. Okay, and let's go to the top. Is our draw function. We don't need this thing. We don't need this thing. Okay, we have a draw rectangle. The rectangle has position X, position Y, width, height, and color. Width, height, and color. So what we can do now is rect equals to Raylib struct actually draw a rectangle which is going to be, let's say, 100 100, then it's going to be 100 100 as well, and then color is going to be, let's create a red color. Color, then R is going to be 255, G is going to be 0, B is going to be 02, and A is going to be 02. Okay, we have a 100 pixels by 100 pixel rectangle now in the screen, which we created using PHP and Raylib. Okay, the next obvious thing is like to move this rectangle, I don't know, so somehow. So we are going to like extract these XY positions into, I don't know, a class. Let's say class state, then let's okay, we have these things here, and then I will just say state equals to new state zero, and then size, let's say, is 100. Size is 100, right? Okay, now what we can do is, instead of this position X, position Y, and then since it's a square, we can have size 2 times position size size. Okay. Oh shit, I initialized this thing twice. Okay, so we start from 0 to 0, I don't know, 0, 0, and we have a rectangle. So in order to move this, we will need to get the animation frame time. So let's see, frame time, get frame time, yeah, 0. Let's do it here. It will return float, so we can do something like delta time equals to $raylib get frame time, and before that we also need to set target FPS. Doing this will so why do we need to set target frame before target FPS before doing the frame time is because if you don't set it, really will try to render in the maximum maximum possible frame rates supported by your hardware, of course. But if we do that, then the code that I write will run like one way in my machine and some other way in your machine. So maybe in my machines, or maybe in your machines, if it's got a great GPU or whatever, it might the animations might be faster than what I intend to make. So so because of that, we need to do Raylib target FPS. Let's do it 60 for now. Let's try to render in 60 FPS. And now I will get 60 FPS text, hopefully. Before we do that, draw text is draw text. Draw text, yes. I need this thing as well because I want to show the we don't need the names of the variables, we just need the and this does not need to be constant star. Okay. And get I also need to get FPS. I want to show a FPS monitor at the top of my screen. So it's going to go here. Get FPS. Okay. Draw text. And what did draw text take in again? It took position X, position Y, font size. Okay. So FPS is going to be RL get FPS, and we'll cast this into string so that it will be an array of characters. Position X will be, let's say, I don't know, 20. Position Y will be 20. Then font size will be like 30. And color will be, let's draw red. Let's draw in red. Or maybe let's, doesn't matter. Position X. We have 800 by 600. So let's do 550 or something like that. Okay, so at the bottom of our screen, we are seeing our frame rate. I could actually make this a bit better if I could just say something like this. So now maybe make it 3 bits smaller. What about 20? Okay, seems reasonable. All right. So we have frame time coming in. We have this delta time. Let's render delta time to dt is going to be dt, and then we will do 570. Actually 580. Let's do. Okay. Yeah, so you can see we have delta time, which is I don't know 0.016, which is 16 milliseconds. Yeah, 16 milliseconds is the time that Raylib is taking to render a single frame, right? Now what we can do next is the okay, it was way too fast. Uh, oh shit. Let's try multiplication. No, it's way too slow. It's to 500 maybe. Okay, and let's check a bounding. 800, then we reset back to hmm. Okay, so this is done. This is the simplest example for this, like how to use Raylib with PHP. But to be honest, that's not what we are here for. This is just the preliminary tasks for the real deal. So, what we have established so far is we have some kind of central animation state, right? And in the render loop, we are like manipulating this states so that the actual like the actual animation can run. But the problem is, let's say I want to let's say I want actually let's render and it'll be easier to explain. So let's say I want this red rectangle to reach here and then wait for 2 seconds and then like I don't know, move down or something like that, right? It's a sequence of instructions. So first of all, like for some duration, you go from left to right till here, and then you wait for a second, like 2 seconds, you do nothing, and then you move down. So there are like three distinct operations that we need to do here. And these can be, I don't know, these can be something like go left for 2 seconds, right? And then go, I don't know, wait for 2 seconds, and then again go down for 2 seconds or something like that, you know? And these are like um, a set of instructions. But if we just like naively implement something like this here, let's say I said, I don't know, sleep for 2 seconds or something like that, then let's see what happens. You see, it actually sleeps on the um, first frame, and the entire application does not open till the time is passed. So we can't really do sleep. So we need to come up with a way that that will allow us to do these things without actually blocking the render loop. And this is where fibers in PHP and the coroutines for the panning they come in. So what coroutines allows us to do is just create some kind of non-blocking operations, non-blocking, I don't know, code execution, right? So in order to do that, now I'll just close this really, oh shit. For now. And I'm getting this red squiggly and errors because yeah, there are there are no actual init window methods in the FFI library or the Raylib class itself. We are just hooking into the internal FFI thing. So that's how it's going on. So now the next thing is we need some kind of class that manages this application or these animations, some sort of fiber scheduler to say, right? So let's create a scheduler.php class, right? And for this, what we are going to do is so in our previous example, I said I wanted the red thing to go from here to here, right? So these kind of operations, like the x value will go from I don't know 0 to 300 or something like that, because it's a or 400. I'm not really sure. Yeah, something like that. And these kind of operations are called twin operations. So you gradually move the value from I don't know, a lower bound to an upper bound um, during like the during a specified period of time or something like that, right? Um, so I will just do it will okay, let's do it this way. Let's public function then we'll say it's target and private object target. All right. So this target is the state that I want to take. So I want to what I want to do now is I want to do scheduler equals to new scheduler with the state, something like this, right? And from here I want to do something like scheduler tween the position x from I don't know 0 to 300 during 0.2525 seconds, or something like this. And we can do again tween position y of this thing from 0 to 200 in the next 0.25 seconds, something like this. Okay, so in order to be able to let's create an API for this. So we have a public function tween, and this is going to be string property, and this is going to be float from, float to, and then another float duration, and it's going to return self so that we can chain methods. So now what we can do is this we can add function to the animation, and we are going to use property from to duration here. Actually, I think I also need the Raylib instance. Private Raylib. What did I do? I don't really need this. Oh shit. strct strip types equals to 1. Okay. So we have an array of animations, and whenever somebody calls tween, then we do something here. And the main so this is going to be the most important thing. This is going to be the most important thing in our library. Use fiber, right? And we also need a function update, which will run on every frame. And let's create a also we're going to need start PRO. And when we do start, we're going to say this animation. Okay, let's go through this one once more. So we create a fiber and did we also start the fiber, and if it's not started, then we start. Then we do something like this. And this update function, we will call this update function in the main render loop. So it will be something like something like this here. And we probably should start this shit right away. Okay. All right. Now we need delta time this time elapsed is less than duration, then we do something like this. Okay. And to actually tween method from what we can do is shit. Let me find how to execute. Uh, Current time minus start time by duration. Okay, let's implement this. X0 plus Y0 minus X0 into P. From plus 2 minus from by into P, and $P equals to, what is it? Current time minus start time by duration. Current time is elapsed, yes. Elapsed minus start time. Start time is what's it? Current time minus start time. Okay, I think we can just do elapse by duration. By then we can do this. Target property equals to $value. I hope this works. Let's see. Let's remove this thing. Are we getting frame time anywhere? Yeah, we don't need this. We don't need this too. Okay. Let's see. Scheduler not found. Okay, it's pretty easy to fix. What else? Argument Raylib must be okay. We forgot to provide Raylib. This is going to be Raylib, and what return value must be of type scheduler, non-returned in scheduler 40. Scheduler line 40. Ah, no. Return this. What else? Cannot assign float to property of int. Ah, fuck it, let's just make everything float. Float, float, float. Okay, now we should be able to assign. Yeah, you see? Okay, good, good. Now we can even slow down the duration to, let's say, 2 seconds. Now what happens? Okay, good enough, right? Now what we can do, let's implement a wait function in the scheduler. So we have wait will take duration and then return self and return this. Okay. Now we can basically copy paste this entire thing here to here, and instead of doing anything at all, we just yeah, we just do this. Wait for 2 seconds. And then let's say wait for 2 seconds again, and let's say tween will be position Y, and then this time it will be from 200 to 0 in 2 seconds, and then we wait 2 seconds again, and then we'll tween position X from 300 to 0 in 2 seconds. Let's see if this works. All right. All right. I think I'm gonna call this a success. And yeah, in the next, I don't know, in the next next stream, if I ever do, we will continue. We'll try to create a really cool animation library with all sorts of animations, ability to do like replay animations and stuff like that. I have a few things that I wanted to do in mind, and hopefully I can get to implement these things. All right. Um, have a good one. Thanks. Bye.